In the autumn of 2017, a small, reddish speck of light tumbled through our solar system at 87,000 miles per hour. It was moving too fast to be captured by the sun's gravity. It didn't have a tail, it didn't look like a comet, and it didn't behave like an asteroid. We called it Oumuamua, the Scout. For a brief, electric moment, the world held its breath. The headlines suggested we were being watched. High-profile astrophysicists suggested it was a light sail, a piece of discarded technology from a civilization that had long since vanished into the void. But while the public was falling in love with the idea of an interstellar visitor, the scientific community was quietly beginning to hate it. This isn't because scientists are cynical or because they fear the discovery of extraterrestrial life. It is because Oumuamua and the objects that followed it did something far more disruptive than merely existing. They broke the math. They shattered our models of how planetary systems form. They triggered a wave of what many experts call scientific circuses, and they forced us to confront a reality where the data we rely on might be a series of elaborate cosmic illusions. The mystery of the alien acceleration was actually solved in 2023, and the answer is far more fascinating than a starship engine, but that solution only opened a much darker door. We aren't just looking at rocks from another star. We are looking at a mathematical crisis that suggests our understanding of the galaxy's mass is fundamentally broken. To understand why these visitors are so problematic, we have to look at the first sin of Oumuamua, the non-gravitational acceleration. As the object rounded the sun and began its exit, it sped up. In the vacuum of space, things don't just speed up unless they are being pushed. If it were a comet, the heat of the sun would vaporize its ice, creating a jet of gas, a natural thruster. But Oumuamua showed no signs of outgassing. No dust, no carbon monoxide, no tail. This led to the famous light sail hypothesis, the idea that the object was so thin and light that the mere pressure of sunlight was pushing it like a sail on the ocean. It was a beautiful, haunting image. It was also, as it turns out, unnecessary. In March 2023, a study published in Nature by Jennifer Bergner and Daryl Seligman provided the boring answer that is actually a masterclass in deep space chemistry. Over millions of years, as Oumuamua traveled through the interstellar medium, high-energy cosmic rays bombarded its icy body. This radiation didn't just sit on the surface, it penetrated deep into the ice, breaking water molecules apart and creating pockets of entrapped molecular hydrogen. When the object hit the warmth of our inner solar system, that hydrogen didn't erupt in a massive, visible plume. It leaked out gently, invisibly, providing just enough thrust to explain the acceleration without ever forming a visible tail. The mystery was solved. The engine was just chemistry. But for the scientists who had to spend years debunking the alien theories, the damage was already done. The Scout had become a catalyst for a new kind of academic warfare. This brings us to the second reason scientists have grown to resent these interstellar visitors: the rise of the scientific celebrity and the commodification of the unknown. No name is more synonymous with this friction than Avi Loeb, the former chair of Harvard's astronomy department. Loeb became the primary champion of the Oumuamua as an alien probe theory, and he didn't stop there. He shifted his focus to the ocean floor. In 2023, Loeb led a high-profile, multi-million-dollar expedition to the Pacific Ocean to recover fragments of what he claimed was an interstellar meteor, Syneos 2014-01-08, which had impacted Earth years earlier. He returned with tiny metallic spheres, Spherules, claiming their chemical composition was extrasolar and potentially technological. The media frenzy was unprecedented, but within months, the scientific community struck back with a precision that was almost surgical. Independent researchers, including Patricio Gallardo, analyzed the data and found that the chemical signature of the spherules wasn't alien at all. It was consistent with terrestrial industrial pollution, specifically coal ash from 20th century power plants. But the most devastating blow came from the seismologists. Loeb had used seismic data from a station on Manus Island to pinpoint the meteor's impact zone. A team from Johns Hopkins University reviewed the recordings and found that the vibrations Loeb attributed to a falling interstellar fireball were actually the acoustic signature of a heavy truck driving past the hospital where the sensors were located. The interstellar messenger was a delivery truck. For mainstream astronomers, this wasn't just a mistake, it was a symptom of a larger rot. They don't like interstellar visitors because these objects have become magnets for sensationalism that distracts from the rigorous, quiet work of actual discovery. But if we strip away the drama and the trucks, we are left with a problem that is much harder to dismiss: the mass budget crisis. This is where the math truly begins to fail. Based on our current models of how stars and planets form, we can estimate how much stuff should be ejected from a solar system during its birth. When a giant planet like Jupiter migrates, its gravity acts like a slingshot, flinging billions of icy rocks out into interstellar space. We can calculate the density of these rocks in the galaxy. When we saw Oumuamua, we thought it was a once-in-a-lifetime fluke. Then came 2I/Borisov, a massive, traditional-looking comet from another star. Then came 3I/Atlas. According to the laws of probability, we shouldn't be seeing this many of them. To have an object like Oumuamua or Atlas pass through our specific tiny neighborhood as often as they do, every single star in the Milky Way would have to be ejecting a staggering amount of mass, far more than their protoplanetary disks ever contained. We are talking about a mathematical tension that suggests either our planetary formation models are off by several orders of magnitude, or there is a mechanism for creating these objects that we haven't even dreamed of. Scientists don't like interstellar visitors because they are impossible guests who keep showing up at the door, proving that our galactic checkbook doesn't balance. The arrival of 3I/Atlas in June 2025 only deepened the wound. Discovered by the Asteroid Terrestrial Impact Last Alert System, this visitor wasn't just another speck. It was a 152,000 mile/hour anomaly screaming toward a rendezvous with Mars in October. While the public was looking for radio signals, early estimates suggested Atlas could be a monster, up to 20 kilometers wide, a size that would have made the mass budget problem insurmountable. While Hubble Space Telescope observations eventually constrained the nucleus to a much smaller size, it still presented a headache, a cometary tail that seemed to defy the standard laws of solar radiation pressure. To some, this was more evidence of artificiality. To others, it suggested we were suffering from an origin illusion. This is the hidden level of the interstellar controversy. What if these objects aren't interstellar at all? What if they are false positives from our own backyard? To understand this, we have to look at the Oort cloud, a gargantuan spherical shell of icy debris that surrounds our solar system, reaching out nearly halfway to the next star. The objects in the Oort cloud are barely hanging on to the sun's gravity. They are at the edge of the cliff. A passing star, a distant brown dwarf, or even the subtle tide of the Milky Way galaxy itself can give one of these rocks a tiny nudge. When that happens, the object can be sent screaming into the inner solar system on a hyperbolic trajectory. To an observer on Earth, its speed and its path would make it look exactly like an interstellar visitor from another galaxy. Recent statistical models suggest that a significant percentage of what we call interstellar objects might actually be native Oort cloud bodies that were kicked by a galactic tide we don't fully understand yet. If this is true, it means we aren't being visited by the neighbors. We are being haunted by our own shadows. It means the interstellar revolution might be a giant misunderstanding of celestial mechanics. To resolve whether these anomalies were mechanical or natural, researchers looked to the European Space Agency's JUICE spacecraft. In October 2025, as 3I/Atlas made its closest approach to Mars, JUICE was perfectly positioned to perform a serendipitous deep space observation of the object. The data it sent back was a cold shower for the alien enthusiasts. It didn't find metal hulls or heat signatures. It found hydroxyl emissions. It found a standard, albeit strange, chemical signature of a comet. It was natural. It was boring. But in that boredom lies the real scientific frustration. The alien spacecraft narrative has become so dominant that the actual incredible reality of these objects, that they are time capsules of exoplanetary geology, is being drowned out. Scientists don't like interstellar visitors because the visitors have become a mirror for our own desperation to not be alone. We are so eager to find a probe that we are willing to ignore the fact that we've found something much more important. A piece of a world we will never visit, carrying the chemical signature of a sun we will never see. And yet, the mass budget problem remains. Even if we account for the Oort cloud false positives, the sheer number of these objects is still too high. This has led to a radical new theory that is currently dividing the field. Some astrophysicists are beginning to propose that interstellar space isn't just a vacuum with the occasional rock. They suggest it might be filled with dark comets, objects that have lost their volatile ices and are essentially invisible until they pass directly in front of a star or enter a system like ours. If the galaxy is teeming with these dark wanderers, it changes everything we know about the distribution of matter in the universe. It suggests that the missing mass we've been looking for in the form of dark matter might have a baryonic component, just trillions upon trillions of silent, dark rocks drifting in the cold. This is a terrifying prospect for a cosmologist. It adds a layer of clutter to the universe that makes every calculation harder. It's like trying to navigate a room filled with invisible furniture. The scientific dislike of these visitors also stems from the circus of speculation and how it affects funding and public trust. When a high-profile scientist claims he found alien tech, only for it to be revealed as coal ash and a delivery truck, the public doesn't just lose faith in that one scientist. They lose faith in the process. They begin to see science not as a rigorous pursuit of truth, but as a series of competing marketing campaigns. The interstellar visitors have forced astronomers into the role of the fun police. They are the ones who have to explain that the mysterious glow is just thermal re-radiation, and the impossible path is just the effect of molecular hydrogen. It is a defensive posture that no scientist wants to be in. They want to be the ones discovering the aliens, not the ones proving the aliens aren't there. As we look toward the future, the Vera C. Rubin Observatory is about to come online. It is expected to find dozens, perhaps hundreds, of interstellar objects every year. The crisis is about to become a flood. When we have a database of 500 Oumuamuas, we will finally have the statistical power to solve the mass budget problem. We will finally know if our solar system is an anomaly, or if the galaxy is simply much messier than our elegant models suggest. But until then, the friction will remain. Scientists will continue to dislike these visitors because they represent the ultimate, unfinished business. They are anomalies that refuse to be categorized. They are the grit in the gears of our understanding. The story of the interstellar visitor is not a story of a first contact that was missed. It is a story of a scientific community struggling to maintain its integrity in the face of a mystery that is perfectly designed to be exploited. It is a story about the limits of our math and the fragility of our data. When we look at 3I/ Atlas or Oumuamua, we shouldn't see a probe or a ship. We should see a challenge to build better models, to launch better telescopes, and to be disciplined enough to follow the data, even when it leads us away from the spectacular and toward the sober reality of a cold, silent, and incredibly crowded universe. The Scout didn't find us. We found the limits of our own knowledge, and that is the most uncomfortable discovery of all. The deeper we go into the data, the more we realize that the alien hypothesis was actually the easy way out. It's a simple narrative. Someone else built it, and they sent it here. The real scientific explanation, the one involving hydrogen gas trapped in ice, galactic tides, and missing mass, is far more complex and far more demanding. It requires us to rethink the very history of our galaxy. If every star is throwing out 10 times more mass than we thought, then the seeds of planets are everywhere. It means the delivery system for the building blocks of life is much more efficient than we ever imagined. The boring answer actually makes the universe feel much more alive, even if there isn't a pilot at the wheel of the rock. But the truck signal debacle still haunts the halls of academia. It serves as a cautionary tale about what happens when the desire for a breakthrough outpaces the requirement for proof. On Manus Island, the seismic sensors were doing exactly what they were supposed to do. They were recording the environment. They recorded the wind, the waves, and yes, the trucks. To take that noise and turn it into the signal of an interstellar fireball requires a level of motivated reasoning that science is built to prevent. This is why the dislike is so visceral. It's a defense mechanism for the method itself. If we accept the truck as a meteor, then the word meteor loses its meaning. If we accept coal ash as alien technology, then technology loses its meaning. The interstellar visitors didn't just bring us data from another star. They brought a mirror that showed us how easily we can be fooled by our own hope. In the end, the visitors are gone. Oumuamua is long past the orbit of Neptune, fading into the eternal dark. Borisov is headed back into the void. Atlas is receding. They came, they broke our models, they started a few fights, and they left. We are left with the data and the realization that the next time one of them shows up, we need to be better. We need to be faster. And we need to be much, much more skeptical. Because the universe is under no obligation to be as exciting as a Hollywood movie. It is, however, under a very strict obligation to follow the laws of physics. And right now, those laws are telling us that we have a lot of work to do. The visitors aren't the problem. Our understanding is. Every speck of light from the interstellar dark serves as a reminder of everything we still don't know. The real mystery isn't who sent the Scout, but why we weren't ready for it when it arrived. Until our models can finally account for these cosmic auditors, the scientific community will continue to look at them with a skeptical, frustrated eye, knowing that right now, our accounts are coming up short.